Welcome to AT Math Academy. Topic for today is law of cosines. In trigonometry, in my earlier videos, I have shown you how to derive the law of sines and the applications for that. Now I'm going to show you how to derive the law of cosines and where it is applied. So for this, let's draw a triangle and let's name the vertices of this triangle as A, B and C. Let's draw the perpendicular and name the height as H, and the side opposite to angle A is A and B is B. C is, this total side is marked as C. Let's say this side length is marked as D, and then this side length would become C minus D. Now let's redraw the two right angle triangles here. To the left hand triangle, left hand side, I have it as C minus D, H and A, and the vertices are B, C. And for the right angle triangle here, to the right hand side, I have my height here and B, and the side length here is D, and the vertices are A and C. Now, according to Pythagorean theorem, we have the square of hypotenuse is equal to sum of squares of other two sides. Now I'm going to apply the Pythagoras theorem. So square of hypotenuse is A square is equal to sum of other two side squares C minus D whole square plus H square for the left hand triangle. And for the right hand triangle, I have here as B square is equal to H square plus D square. Okay, these are the two equations. And from this triangle here, I have it as B square is equal to H square plus D square. So we can imply that H square is equal to B square minus D square. Okay. Let's mark the first equation for the left hand triangle and the second equation for the right hand side. Now I'm going to apply the trigonometric ratio of cos. As it is law of cosine, I'm going to apply the cos angle here for angle A, the right hand side. So cos of angle A is nothing but adjacent side over hypotenuse. So cos of angle A would be adjacent side is D, hypotenuse is B. Okay. And from this, I have it as D is equal to B into cos A. Let's name this equation as number 3. Now, I'm going to resubstitute this equation 3 in equation 2. So let's rewrite the equation 2 here. H square is equal to B square minus D square. Here, H square is equal to B square minus D square from the second right angle triangle. And I'm going to substitute the cosine of angle A application here. And the side length D is B of cos A. In this equation, H square is equal to B square minus, and in the place of D, I have it as B cos A whole square. Okay. And now let's name this equation as equation 4. So now I'm going to take my first hand equation, which is A square is equal to H square plus C minus D whole square, and rewrite here A square is equal to C minus D whole square plus H square. Now I'm substituting my fourth equation into the first equation because the height is common for both of these triangles, so H square value should remain same. So A square is equal to C minus D whole square plus, for H square I have it as B square minus B cos A whole square. B square minus B cos A whole square. And again I can insert my D value from third equation as B cos A here. So let's do that. A square is equal to C minus B cos A whole square plus b square minus b cos a whole square can be written as b square cos square a. And now let's apply the a minus b whole square formula here. A square is equal to c square a square plus b square. For the value of b I have it as b cos a, so it would become b cos square a minus 2 into a into b. So a here is c and b here is b cos a, so b c cos a, and I have it as b square and minus b square cos square a. So plus b square cos square a and minus b square cos square a gets cancelled out, and I'll be remaining with a square is equal to b square plus c square minus 2 into b into c into cos of angle A. So this is nothing but law of cosine. So this is how the law of cosine has originated, and this is a recap of the total glimpse of the problem here. I'm going to re-explain it to all of you. So imagine this triangle, and to the left I have this right angle triangle and to the right I have this, and we are applying the Pythagorean theorem and writing two equations for these two triangles. So a square is equal to c minus d whole square plus h square is first equation, and for the second it is b square is equal to h square plus g square. So from this equation I am rewriting my h value. H square is equal to b square minus g square. Now as it is law of cosines, I am applying the cos of angle A to the second equation, which is cos A is equal to adjacent side, which is d, over hypotenuse, which is b, d by b, and d is equal to b into cos A. Now I am going to substitute this d value in equation number 2 here. H square is equal to b square minus b into cos A whole square. Now I am going to substitute this h square value in first equation because the height is common for both of these triangles, so h square value should remain c. So rewriting my first equation here, a square is equal to c minus d whole square plus h square, and substituting my h square value from the second triangle into the first equation, I have the formula over here, and b of cos a whole square can be written as b square cos square a, and c minus d whole square can be written as, for d I'm going to take the value as b into cos A from equation 3, which I got it by applying cosine of angle A for second triangle. So after rewriting this and applying a minus b whole square to this and this gets cancelled out, and I'm left over with a square is equal to b square plus c square minus 2 into b into c and cos of angle A. So law of cosines can be written as, now if we want to write for b square, we can write it as a square plus c square minus 2 into times bc here. So here we have times ac cos of angle A, which means we have cos of angle B. And for c square we can rewrite it as a square plus b square minus 2 times a into b into cos of angle C. So these are the three formulae for law of cosines. So hope you all like my video, and please subscribe to AT Math Academy and enjoy doing math at AT. Thank you for taking time to watch this video.